Hi guys, welcome back to our YouTube channel. So in today's video, we'll be looking at this differential equation. We are asked to solve this on differential equation using Laplace transform. So I'm going to be transforming this differential equation into a Laplace transform. I'm going to be transforming into Laplace. Then we'll be able to solve this differential equation. So without wasting much of our time, let's dive into the action. So as you can see, we are given y prime, that is, this is d square y dx square. So this is the second order derivative. So given y on prime prime plus 8y prime is equals to 0, and we're given the initial value problems, which is on y of 0 is equals to 3, then y prime of 0 is equals to 8. So now let's solve this. So the first thing we're going to do is we're going to be transforming this into Laplace function. I'm going to be transforming it into the Laplace domain. So now all we just do is apply Laplace. But then to apply Laplace to this differential equation, we have this standard Laplace table or standard Laplace formula to transform this sort of differential equation. So to transform differential equation of 1, that is to transform y prime. Uh, to transform y prime, it is s y of s minus y of 0, then for y prime prime. Now to transform y prime prime, we have s squared is equals to y of s minus s is equals to y of 0 minus y prime. So this is the transformation we'll be applying to this given differential equation now. So let's apply our Laplace to the equation given. So applying and this will give us this, like applying linearity. So like I said, from this our standard transform of this differential equation, so this Laplace of y prime prime will be s squared y of s minus s y of 0 minus y prime of 0. Then this is a constant. You can bring the constant outside of the Laplace. Then Laplace of y prime will give us this. So put this in brackets. S y of s minus y of 0. And then Laplace of 0 is 0. So now let's simplify this. We have s squared y of s minus s y of 0 y prime of 0, and this gives us 8s y of s minus 8 y of 0 is equals to 0. So now don't forget, you are given some initial statement. They said y of 0 is 3, then y prime of 0 is 8. So let's insert it here so we can go ahead. So this is s, don't mix it up as 5. This is s, the s domain. So now we are given y of 0, which is, say, is 3. So times 3 minus, then y prime of 0 is 8, then plus 8s y of s minus 8 times y of 0 is 3. 3 is equals to 0. Then Now let's try to rearrange. Let's bring this s together. So this is plus 8s y of s. Then this is, okay, this is s not 5. Then minus s times 3, that is 3s. Then this is minus 8 minus, then 8 times 3. 8 times 3, that is 24. Then 24 minus 8 will give us minus 32, which is 0. So now this is our answer for the first box in the question. We are given like 4 boxes. We should fill 4 boxes. So the first box they ask us to fill, this is what we're going to be filling inside. So let me put it in a box. So this is what they ask us to put inside the first box. So this is it. So now I've converted these differential equations into the Laplace domain now. So now what we just need to do is to to isolate it so that we'll be able to get y of s, which is our Laplace domain. Then we will apply the inverse Laplace to return it back to the original function. So now let's do that. So, and for this and this, y of s is common, so let's bring y of s outside. Then we have s squared plus 8s. Then we have minus 3s minus 32. Don't forget this is s, not 5, please. So now we can take this to the other side. Y of s squared plus 8s. Then this becomes 3s minus plus 32. Then let's isolate y of s. So we divide both sides by s squared plus 8s. So this gives us y of s is equals to 3s plus 32 all over s squared plus 8s. Now this is the second box we are asked to fill. So let me put it in a box. So this is the second box we are asked to fill. We have just gotten the y of x. We have isolated the equation, then we have gotten our y of x now. Now the next thing to do is to apply inverse Laplace. So this can become y of t. That is, returning back to the time domain. So then that will give us our final answer to this differential equation. But then to be able to do that smoothly, the first thing we'll do is break this down into partial fraction. And we can see in the next box there, they ask us to put this into partial fraction. So now let's move to the side now. Y of s equals 3s plus 32 all over s squared plus 8s. So which I can say this is 3s. Don't forget it's s, not 35. S is common here. Can say s plus 8. Now let's take this as partial fraction and then deal with this first. 32 over s plus 8. Then converting this to partial fraction, we're going to be having a over s plus b over s plus 8. These are s, not 5, please. S. So now, we're going to be solving this to get our value for a and b. Then we insert it. Then we are done for the partial fraction part. So now, do this. You can see this here. S plus 8. So s plus 8, s in s here, we are left with this. So as plus 8 plus this, and s times b, are left with bs. So now to this cancel this here, so we are left with 3s plus 32 is equals to as plus 8 plus bs. Now to get our value for a and b, we are going to be given the value s. We are going to be given s a value. So now for easy purpose, we are going to be using the value that we eliminate one of these variable that we're trying to get. So now the first one is to let s be 0, because by the time we put 0 here, b will be eliminated. So we're left with only one unknown. So now that's the logic we're going to be applying here. Let s is equals to 0, then 3 0. You see s now, we put 0. 32 is equals to 0 plus 8 plus b 0. So we're left with 32 is equals to 8a. Then a is equals to 32 over 8, which is 4. So that's our a. Now for to get b, so we need to eliminate a. Then what can eliminate a? Check here, s plus 8. So when we equate this to 0, this becomes s is equals to minus 8. When we input minus 8 here, this a will be eliminated. So now let s is equals to minus 8. So anywhere we see s, let's start minus 8. 3 into minus 8 plus 32 is equals to minus 8 plus 8 plus b into minus 8. So then this 3 times minus 8 is going to give us, this gives us minus 24 plus 32. Because of this, a is eliminated, so we are left with minus 8b. Minus 8b, then this gives us 8 is equals to minus 8b, then b becomes minus 1. So this is our value for b. So I'm putting our value for a and our value for b. So now all we need to do now is to insert it in our partial fraction. Now we said this is 3s plus 32 s plus 8. We said is a over s. Then what is our a? Our a now is 4. It should be 4 over s. Then we forget our plus. Then what is our b? Our b is what? Minus 1. Minus 1 over what? S plus 8. So now we have gotten this partial fraction. So in the second box now, they ask us to do this second box. Sorry, in the third box. So we just need to do this. Insert 4 over s. Yeah. Don't forget this is s, not 5. Then plus is given in between. So in the second box, so we're going to be inserting minus 1 over s plus 8. So this is it for the third box. This is it for the third box. So this is what will be inserting. So now for the final box, which is our final answer, the y of t now. Y of t now, which was into this now, we have gotten the partial fraction of this y of s. To apply, let's apply inverse Laplace. Inverse Laplace. So we just need to do this when we take the inverse Laplace of y of s, we are going to end up with, let's write it first, inverse Laplace of y of s, then inverse Laplace of 4ys plus inverse Laplace of minus 1 over s plus 8. So this will give us y of t, then inverse Laplace of 4 over s. Then don't forget, this 4 is a constant. We can bring it outside. Take the inverse Laplace of 1 over s. Then this as well, minus we can bring minus outside of this. So this becomes inverse Laplace of 1 over s plus 8. Then y of t equals, and from our table of Laplace transform, we know that when we take the Laplace of 1, it is 1 over s. So the inverse of 1 over s will give us 1 back. So and 4 times 1 is 4. Let's do it like this. Inverse Laplace of 1 over s is 1. So don't forget that is our standard Laplace values and Laplace table. So the same thing apply here. This is 1 over s plus 8. Then going back to our standard table of Laplace, okay, let me just do a table here. Let me do a table here. So let me show you the function. Let me call this f of t. Then the f of s is here. So when we take the Laplace of this, it will give us 1 over s. Then we also have the exponential function where we have at. So this will give us 1 over s minus a. So now this is just one of the many tables of Laplace we need to know. This can be gotten from the formula for Laplace, the integral formula. So now we're not trying to derive anything here. These are common Laplace values that we know because they are basic one we use every time to solve Laplace transform. So what I'm trying to say now, the inverse Laplace of 1 over s plus 8, you see that is very related to this exponential function. All we just need to do is to make sure that our a now, we have 1 over s minus a, but here we have s plus 8. So all we just need to do is make sure our a will be minus 8. Our a now need to be minus 8. So instead of exponential 80 to be exponential minus 8t. So now this gives us exponential 8t. So now this is our final answer now. 4 minus exponential 8t. So this is our final answer for this question and this problem. So I believe we understand this Laplace transform very well. So this means also the end of today's video. Thank you very much. Please subscribe and like, please.